Welcome everyone. Firstly, I'd like to thank for Global Hands-on Universe for issuing the program and also for the National Academy of Geo and Space Science for conducting the program to us. Now, let me talk about some of the major topics that we have done on the second day of the program. At first, open the window of Stellarium and place the location as Kathmandu, Nepal and add it to the list. Then secondly, choose the special date and time. Here we have choose the longest day, that is June 21, and the time is 5:12 where the sun just rises. Then we noted the observed data as azimuthal angle and the altitude of the sun as it passes through the sky in every interval of an hour. The speed of the sun is maintained by the lower right key, which is on the desktop, and also the azimuthal angle and the altitudes are noted from the left top corner of the window. Now the observed data are placed on the Microsoft Excel and use it to plot the graph between time, altitudes and the azimuthal angle. This is the graph between the azimuthal angle and the altitudes. As the azimuthal angle increases slowly, we can find here the sharp increase in the altitudes. After 11 am, the sharp increase in the azimuthal angle tends to increase as slow in its altitudes. After 1 pm, altitude decreases sharply in a short increase in its azimuthal angle. Here, red line indicates the altitudes and it is regular increasing and decreasing, which is almost all circle. And the blue line indicates the azimuthal angle after 11 to 1 pm. Here in between the 11 am and 1 pm, we can find the sharp increase in the azimuthal angle. That means it takes a turn from east to the direct west. This is a combined graph which is plotted against the time, the both altitudes and the azimuthal angle. Here the red line indicates the altitudes and the blue line indicates the azimuthal angle. This is our second work to make a telescope. Here we have taken pipe of about 40 cm long and 2 inch in its diameter, and the second one is 10 cm long and 1 inch in its diameter. The small pipe is rolled or coiled through the papers. You can see here in the picture. The larger pipe diameter should be equal to the lens size. The stand is being fixed here. We have used all the homemade raw materials like a board, ply, knot, screw. And the eyepiece and the lens are fitted on the pipe with the help of tape and glue. Finally, the stand is ready and the telescope is also ready. Now it's the time to fit the telescope on the stand. In order to fix it, we have used some of this type of apparatus or materials and fixed it on the movable stand. Now it is the time to observe the object through the homemade telescope. With the help of singly used lens in this telescope, we can notice that the object comes nearer, but the object will be in the inverted state, since the single lens is used over here. On the next topics, we have found the diameter of the black dot which is placed on the balloon and compare it to the size of the balloon. For this, we have used GHOU software. The balloon was first blown up to 17 cm in its diameter, and from the 1.5 meter far, we have taken a photo shot with the help of our smart mobile. Then on the GHOU software, we have opened the picture. We zoom the balloon and measure the length of the diameter of the balloon with the help of GHOU. And we clicked on the analyze and plot profile, from which we can find the diameter of the balloon in pixel. The initial and the final reading are subtracted and we find the difference. And also we measure the diameter of the black dot which is present on the balloon, and numerically we calculate the value. In our experiment, we found that the diameter of the balloon is 17 cm and it is 150 cm far from the camera. By using the GHOU software, the total, that is the distance in a pixel, that is the diameter of the balloon in pixel, is 309 pixel and the diameter of the black dot is 49 pixel. We converted the pixel into the centimeter by using the unitary method, and finally we got the result, that is the diameter of the black dot is found to be 2.71 centimeter. Lastly, now it's the time to observe the moon directly by using the telescope focus. This was our first experiment that we have ever done. We have used this telescope in order to observe the surface of the moon and also its crater. Now it's almost all 6 p.m. where we can see just a half moon here today. We observed the half moon with the help of this telescope. The figure we have seen was amazing. We could see the surface of the moon and its crater too. Thank you for watching this video.